Welcome back. Today we're going to talk about the zeros of polynomial functions. This is going to be something where we're looking at finding the zeros of something that's like an x to the fourth or an x to the fifth. Let's start out by talking about the number of zeros because it always helps to know what we're shooting at. How many are we actually looking for? And the general rule here is going to be for a polynomial of degree n, for example, like f of x equals, x to the n plus da 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 da, so that highest degree polynomial, then there are n zeros that are complex numbers. Okay, so this could be, where you've got 3 plus 0i, so it could be just a real number or it could be an imaginary number. So that's real and or imaginary. Okay, so we know we're looking for n zeros. So if it's x to the fifth equals 5 zeros. Okay, so that's going to help us know what we're shooting at, because as we get into this, we're going to figure out what the rational ones are that we're looking for, but also we know that ultimately when we break it down using synthetic division or graphing or whatever, a combination of both, we're going to end up with a certain number of zeros. So here we go. So if we're finding the zeros of the function, we're not actually going to be finding the zeros in this example, but I want to show you a couple of things. Okay, so for example, this is x to the first, so there's 1 0. It's x equals 2 because x minus 2 equals 0, so x equals 2. All right, so we knew there was only one. So I'm not sitting here thinking, well, is there a complex one? Is there something with an imaginary number? No, it's 1 because it's x to the first. For this x squared one, what we're going to see is this is a perfect square trinomial. So x minus 3 squared is going to be the factorization of this. Well, this is really equal to x minus 3 times x minus 3. So even though it's the same, that's called multiplicity. So it's 2 of the same. There's still 2 zeros. So it's x minus 3 and x minus 3. So 2 zeros. In this one, we'd have 3 zeros. And what this one would look like is we'd have x, so I would factor out an x, and then I'd have x squared plus 4, so I'd have x minus 2i and x plus 2i. We're not really super concerned about how to find this. We'll look at that in a minute, but we've already kind of looked at it in previous chapters. But this is a possibility. So here are my 3 zeros, 1, 2, 3. So any of those could be set equal to 0. In this case over here, we've got 4 zeros. And when I break them down, I'm going to have x equals, so x minus 1, so x equals 1. I'm going to have x plus 1, and another x plus 1, and an x plus I. So in this case, I've got multiplicity, so there's 2 of them here. So there's 2 of the same. And I also have an imaginary one, and I've also got a real one over here for x equals 1. So in this case, there are 4 zeros. 2 of them happen to be the same, so the number of numbers, if that makes sense, is 3, but there's actually 4 because of multiplicity. Okay, and so that's how this works. Once we figure out the highest degree of the polynomial, that's how many zeros we're looking for. And it makes sense. Like an x to the fourth term, I'm going to need to have 4 x's to get that up to the x to the fourth. So as I keep going here, we're going to look at how do I find them? And what we use is the rational zeros test. And this is going to tell us the possibilities. So it's going to tell us the possibility. So it's going to tell me, what am I even looking at? Because there's an infinite number of zeros that are rational. So that's like 5, 6, 7, 8, but also 2/3, 1/3, 1/4, minus 1/8. So anything that's an integer over an integer is possible. So there's an infinite number of them. So this is going to tell us a possibility. So it's going to take it from the infinite number of zeros down to, maybe 5 or 6, maybe 30, but still less than infinity, which is good. This is a good thing. And so how do we find the rational zeros that are possibilities? When I look at this, it's going to be a rational zero equals P over Q, which is really equal to, well, that doesn't really mean a whole lot. Where the heck do P and Q come from? It's going to be the factors of the constant term over, so it's a fraction because it's a rational number, over the factors of the leading coefficient. Okay, so we're going to basically come up with a list of things on top and a list of things on bottom. Let's see how this works in action. So we're going to find the rational zeros of this polynomial here, this trinomial. And so what I'm going to do is I'm going to list the factors of the constant term. Okay, and so for P over Q, I'm going to list on top, what are the factors of 1? Well, that would be plus or minus 1. Okay, and on bottom, it's the factors of the lead coefficient, which in this case happens to be 1. So I've got plus or minus 1 again. And so my possible rational zeros are equal to, well, if this was a positive over a positive, it would be 1. If it was a negative divided by a negative, it would be negative 1 over negative 1, so it would be 1. I could also have the situation where I have a negative on top, positive on bottom, so that would be negative 1. Or I have a positive on top, negative on bottom. Now what you're going to notice is we only end up with 2 possibilities in this case, 1 and negative 1. And so testing them, knowing that they're zeros, if we plug them back in, so like f of negative 1, I'm asking the question, does that produce a 0? Does it make the expression equal to 0? And if I do this, I'm going to have negative 1 cubed, and then I'm going to have plus a negative 1, and then plus 1 on the end. So I'm just evaluating it at negative 1. And so that's going to be negative 1 plus negative 1 plus 1, so it'd be negative 1. So this is not a 0. And so actually, this one, not a 0. If I evaluate it at 1, I'm going to have 1 plus 1 plus 1 was just equal to 3. So this one actually doesn't work. Well, what does that even mean? Well, that means there are no rational zeros. Okay, so no rational zeros. What does that mean? Well, that means that it just isn't a whole number and it isn't a rational zero. So it's going to be an irrational number. Well, that's okay, because it still could be like a square root of 3. It still could be a square root of 2. That's all right. Okay, and so that just is part of the process. So let's talk about this next one, because here we have a bunch of terms and we have something that's not a 1 on the end. That made it a little bit easier. And so if I do my P over Q evaluation, my possible zeros are going to look like this. So I can put, plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1 on top. On the bottom, I need to use my lead coefficient, which is 1, so plus or minus 1. So what are my possibilities? If I break it down, think about it in terms of what the denominator is going to be. So if the denominator is 1, either a positive or a negative, it breaks down to a plus or minus 6, plus or minus 3, plus or minus 2, and a plus or minus 1. Because on the bottom is always going to be 1. So if this was negative 6 over negative 1, it'd be 6. If it was negative 6 over positive 1, it'd be negative 6. If it was so it breaks down to just these possibilities. Well, so that's still 8 possibilities. And so having 8 possibilities is a lot, but think about what it could have been. It could have been thousands, millions of zeros. And we've broken it down to 8 possible rational zeros. So how do we use this information in this case? Well, we could find a zero by going and plugging in each one of these to find a zero, which works, which we could do. But at the same time, we can also look at the graph for the possibility. So if I see on my graph that I've got one close to 6, and I think it might be a 6, well, hey, maybe I test that one. If I see that there's nothing in the vicinity of 3, I can eliminate those. These are just the possibilities. It doesn't necessarily have anything to do with the function itself. All right, using the rational zero test. So we found rational zeros for the previous one. It had a coefficient of 1. So let's look at this next one because I've got a coefficient of 2, and so let's see how that works. Let's go P over Q again. And on top is going to be the factors of my constant here. So I've got plus or minus 3 and plus or minus 1. On the bottom, need to go factors of 2. So plus or minus 2 and plus or minus 1. What that's going to give me is plus or minus 1, plus or minus 3, plus or minus 1/2, because I could have 1 over 2, okay? But I could also have negative 1 over 2 or 1 over negative 2. And I can also have a plus or minus 3/2, okay? So I've done all the possible combinations. Well, look at that. I've got this humongous polynomial, and I've narrowed it down to 8 possible zeros. And so what am I going to do? I'm going to test these. And we're going to find one. So we're going to find a zero. Well, what have we been doing with that? Well, once I find one zero, I can use synthetic division to break it down. Okay, so if I looked at a graph, I would find that 1 actually makes this a 0 because my graph would be going through 1, and so then I'd take my 1, I'm going to rationally, or I'm going to use my synthetic division, so 2, 3, negative 8 plus 3, so that's what we did the other day with taking the graph and looking at it and testing a 0. So I see that it goes through 1, so I'm going to use that for synthetic division. So as I go through, I'm going to multiply. So I brought this down. I'm going to multiply here. I'm going to add. So I got 5. So I've got negative 3. So then negative 3 here and 0. Remainder of 0 means it goes in. And so as I factor, f of x is equal to my x minus 1, because that would be 1 as a 0, so x minus 1 is what goes in the parentheses. And then I've got 2x squared from this here, plus 5x minus 3. And then I can continue to break this down. So I can break down this polynomial using asterisks. So I'd have minus 6 on top. I'd have 5 on bottom, so then I'd have 2 and 2. And I'd have negative 1, negative 6, so this would be 1 over negative 3. So my factorization is x minus 1, 2x minus 1, and x plus 3. So what did I just do? I used my graph, but I allowed myself to know a rational zero from using my equation up here and my rational zeros test. So I just look at my potential zeros, look at my graph, and check it out. Okay? That's how we break these down.